We've all experienced minor blackouts. Squirrels like Chippy can cause minor blackouts by chewing through wires, causing damage to local transformers. But have you ever experienced a major blackout? On August 14, 2003, a tree branch in Ohio short-circuited a single high-voltage power line. Within 20 seconds, over 50 million people in 8 states and 2 provinces lost power. A number of ways in which our grid system is set up make it vulnerable to blackouts. Power lines across the country are interconnected in 3 massive networks, allowing power to travel long distances and reach many people. However, the interconnectedness of these power lines and their ability to only carry so much power, we call this maximum capacity, also creates vulnerabilities within the system. On this hot August day in Ohio, everyone was running their air conditioning, meaning that an unusually high voltage was running across the power lines. When a single power line failed, the power jumped to another line, and because this line was already at maximum capacity, it short-circuited as well, meaning its power went to another line, short-circuiting that one, and, well, you get the point. Sequentially, power line after power line was knocked out, allowing cascading blackouts to occur until someone shut off the power. Although the technology exists to automate the system, shutting off power immediately should there be a failure, this technology is not being used currently. Most electricity in the U.S. is produced by coal-fired power plants, where it is then transmitted to cities via high-voltage power lines. Utilities use these high-voltage power lines because it reduces the amount of energy lost in transit and therefore brings down their costs. This high-voltage power needs to be transformed at various substations to step down the voltage so that the power entering your home is at 120 volts rather than 115,000 to 800,000. To learn more about the structure of the grid, look for our video on grid structure. The good news is there are a lot of improvements we can make to our current system that would make our grid more resilient. The technology already exists for an instantaneous, automated response to failed power lines that could cause cascading blackouts. Unfortunately, that technology is not currently being used. Furthermore, building microgrids would make it easier for us to get more of our energy from renewable sources, cut the cost of building transmission lines and power plants, and give us more local control. For more information on the benefits of a microgrid system, see our video specifically on microgrid and smart grid systems.